Pipistrel Nuva Phi 300. The Pipistrel Nuva Phi 300 is a cutting-edge, unmanned hybrid electric vertical takeoff and landing cargo aircraft designed to revolutionize aerial logistics. Developed by Pipistrel, a Slovenian light aircraft manufacturer, the Nuva Phi 300 combines the efficiency of fixed-wing flight with the versatility of VTOL capabilities. The Nuva Phi 300 features a tandem wing configuration with a fuselage length of 11.3 meters and a wingspan of 13.2 meters. Its cargo hold, accessible through the nose, can accommodate up to 3 Euro pallets, offering a volume of 3 cubic meters. The aircraft is equipped with 8 independent electric motors for vertical lift and a rear-mounted internal combustion engine for forward propulsion, enabling it to carry payloads up to 460 kilograms over distances exceeding 300 kilometers. The Nuva Phi 300 utilizes Honeywell's compact fly-by-wire system for autonomous flight control, allowing for predefined flight planning and real-time adjustments via a ground control station. This system enhances safety and reliability, making the Nuva Phi 300 a promising solution for cargo delivery in remote or hard-to-reach areas. Deep Robotics Lynx M20. The Deep Robotics Lynx M20 is a rugged, mid-sized wheeled-legged robot engineered for extreme terrain and industrial applications. Its hybrid locomotion system combines the speed of wheels with the agility of legs, enabling it to traverse diverse environments, from rocky slopes to muddy wetlands, with ease. The robot's robust design allows it to climb 80 centimeters obstacles, tackle 45 degrees inclines, and achieve speeds up to 18 kilometers per hour. Equipped with dual 96-line LiDAR sensors, wide-angle cameras and omnidirectional obstacle avoidance, the Lynx M20 autonomously navigates complex terrains. Its IP66 rated chassis ensures protection against dust and water, while operating efficiently in temperatures ranging from -20 degrees Celsius to 55 degrees Celsius. The robot supports hot swappable batteries, offering up to 3 hours of runtime and a 15 kilograms payload capacity. Its modular design allows for customization with various sensors and tools, making it ideal for tasks like infrastructure inspection, emergency response, and hazardous material handling. KTV Working Drone. The KTV Working Drone is an innovative autonomous aerial system engineered for high-rise window and facade cleaning, offering a safer and more efficient alternative to traditional methods. Its design features a robust drone equipped with specialized mounting equipment and cleaning apparatus, including high-pressure nozzles that utilize a purified heated water system. This brushless cleaning method ensures surfaces are cleaned without mechanical abrasion, preserving the integrity of the building materials. The drone incorporates a patent-pending safety mechanism to prevent falls during operation, enhancing safety for both the equipment and the surrounding environment. Advanced sensor technology enables the drone to maintain precise distances from building surfaces, allowing for centimeter-level accuracy in cleaning tasks. The KTV Working Drone can clean up to 1,200 square meters per hour, significantly reducing the time and cost associated with manual cleaning methods. Its autonomous capabilities eliminate the need for scaffolding or lifts, minimizing risks to human workers and reducing disruptions to building occupants. Bionic Flying Fox. The Bionic Flying Fox is a bio-inspired robotic system developed by Festo, modeled after the real flying fox, a type of fruit bat. It features an ultralight skeleton made from carbon rods and 3D printed components, covered with a flexible, elastane membrane that mimics biological skin. This membrane is tear-resistant and self-healing, allowing smooth and resilient flight. The wingspan measures approximately 2.28 meters, and the device weighs only 580 grams. It has a system that integrates onboard electronics with external motion tracking and control units. Two small motors, connected via a sophisticated tendon system, control the wing movements, replicating natural flight patterns. It has an external motion capture system that continuously tracks its position and adjusts the wing beats and steering in real time. Data is transmitted wirelessly to optimize stability and maneuverability. This interplay between lightweight construction, intelligent control algorithms and precise actuation allows the bionic flying fox to execute autonomous and semi-autonomous flight with remarkable agility and efficiency. Robird. The Robird is a bio-inspired robotic bird developed by Clear Flight Solutions, designed to mimic the flight and appearance of a peregrine falcon. As an ornithopter, it achieves flight through flapping wings, replicating the natural motions of birds. Robird's frame is constructed from lightweight materials, featuring foam wings with a laminated resin skin that provides both flexibility and durability. The wings are driven by two spars connected to a brushless DC motor, enabling both flapping and pitching motions. The onboard electronics comprise an ArduPilot Mega Autopilot system, equipped with sensors such as a 3-axis gyroscope, accelerometer, and barometric pressure sensor for state estimation. Robird operates by emulating the flight patterns of a hunting peregrine falcon, which naturally deters other birds from the area. Its realistic appearance and behavior exploit the instinctual fear responses of pest birds, making it an effective tool for wildlife management. The device can be remotely controlled, allowing operators to direct its flight paths over areas like airports, landfills, and agricultural fields. By leveraging the natural predator-prey dynamics, Robird offers a humane and efficient solution to bird-related challenges in various industries. X-Tinecopter. The X-Tinecopter is a groundbreaking hybrid vehicle that seamlessly merges the rugged capabilities of an all-terrain tank with the agility of a quadcopter drone. Its robust chassis is constructed from reinforced aluminum alloy and carbon fiber, offering superior durability while remaining lightweight for flight operations. On the ground, the X-Tinecopter utilizes high-torque, rubberized tracks that allow it to traverse rough terrains, including sand, mud, and rocky surfaces, with ease. When airborne deployment is needed, 4 foldable brushless rotors rapidly deploy from the chassis, enabling vertical takeoff and stable flight. The propulsion system is powered by a dual-mode lithium polymer battery, optimized for both ground endurance and aerial efficiency. Advanced onboard sensors, GPS navigation, and a real-time HD camera suite provide precise control and situational awareness. With its seamless transition between driving and flying modes, the X-Tinecopter is perfect for reconnaissance, search and rescue missions, and dynamic exploration in environments where versatility is key. Airbound TRT. The Airbound TRT is a revolutionary delivery drone engineered for maximum efficiency, lightweight construction, and cost-effective operation. Developed by Bengaluru-based startup Airbound, the TRT drone integrates a blended wing body design with a tail-sitter vertical takeoff and landing configuration, enabling vertical takeoffs and landings without additional moving parts or propellers. Constructed from advanced carbon fiber composites, the TRT drone boasts an all-up weight of just 2.5 kilograms, including a 1 kilogram payload capacity. Its aerodynamic design achieves a lift-to-drag ratio of 12, with aspirations to reach 20 in future iterations. This efficiency allows the drone to cover distances up to 100 kilometers, making it ideal for applications like rural healthcare deliveries. With a manufacturing cost of approximately $700, the TRT drone is a significant advancement in making drone deliveries economically viable, aiming to reduce delivery costs to just a few cents per mile. Bionic Wheelbot. The Bionic Wheelbot is a bio-inspired robot developed by Festo, modeled after the flick-flack spider found in the Sahara Desert. This spider exhibits a unique mode of locomotion, combining walking with rapid somersaulting to navigate its environment efficiently. The Bionic Wheelbot features 8 legs controlled by 15 small motors integrated into its knee joints and body. 14 automatic locking worm gear units ensure energy efficiency by requiring power only during movement, not to maintain posture. Each leg incorporates spring mechanisms in the joints, storing and releasing energy to aid in motion. An onboard inertial sensor continuously monitors the robot's orientation, enabling precise control during transitions between walking and rolling modes. In walking mode, the bionic wheelbot employs a tripod gait, using 6 legs for movement while keeping 2 folded. To initiate rolling, it transforms 3 legs on each side into wheels and extends the previously folded legs to push off the ground, propelling itself forward. This rolling motion allows the robot to move twice as fast as walking, even on inclines up to 5%. The seamless transition between walking and rolling enables the bionic wheelbot to adapt to varying terrains, mirroring the adaptability of its natural counterparts. Richter Skyrider X1. The Richter Skyrider X1 is an advanced next-generation personal aerial vehicle designed for luxury and precision flight. Its sleek, aerodynamic carbon titanium composite frame offers both exceptional strength and lightweight agility. The Skyrider X1 features a dual-rotor lift system with counter-rotating blades housed in protective nacelles, ensuring stable vertical takeoff and landing capability. Integrated winglets deploy mid-flight to enhance forward thrust and maneuverability, powered by a hybrid electric propulsion unit that combines quiet electric lift with a turbojet booster for high-speed cruising. The cockpit is encased in a panoramic electrochromic canopy, offering a 360-degree view while regulating light and temperature. Advanced avionics include AI-assisted navigation, auto-stabilization, and obstacle avoidance sensors, ensuring effortless control for pilots of all experience levels. With a flight range of 50 miles and speeds up to 30 miles per hour, the Richter's Skyrider X1 is engineered for both urban air mobility and exhilarating cross-country journeys.